Okay, vectors, page 1. Part A, vectors and scalars. Give another word for magnitude. Well, maybe you know this from physics or some other area, but basically magnitude means size. Quantities with only magnitude are called scalars. Okay, so in like physics or math, when we talk about a number that doesn't have a direction associated with just a size, it's called a scalar. Quantities with magnitude and direction are called vectors. Okay. Speed and velocity sound like the same thing, but there's a difference. Explain. Well, speed, as you might remember from physics, is a scalar, no direction associated. And velocity is speed with a direction associated, so it's a vector. Okay. Directed line segment representation, draw an example. So usually a vector is drawn as a line segment with an arrow going in one direction. Okay, so that is usually the way it looks. 12A1. Using a scale of 1 centimeter represents 10 units. Sketch a vector to represent 30 newtons in a southeasterly direction. So southeast is like that, right? 45 degrees. 30 newtons. So if we drew this 30 centimeters long, no, actually not 30 centimeters long, but 3 centimeters long, then that would be equal to 30 newtons, because it says 1 centimeter represents 10 units. An excavator digging a tunnel at a rate of 30 centimeters per minute at an angle of 30 degrees to the ground. So how do we draw this? Okay, 30 degrees to the ground. So the ground, let's draw the ground kind of green. And then the tunnel is at 30 degrees to the ground, so that would be about 30 degrees. And he's digging it at a rate of 30 centimeters per minute, so this is 30 long, 30 centimeters a minute. Okay. All right. If this represents a velocity of 50 meters per second due east, draw a directed line segment representing a velocity of 100 meters per second due west. Okay, 100. So like it should be twice as big as that one, and it should go in the other direction. So I drew that a little bit too long. So twice as long as that one in the opposite direction, west. Okay. All right, number 3. Draw a scale diagram to represent the following vectors. A force of 30 newtons in the northwest direction. Okay. Northwest direction. A displacement of 4 units at an angle of 15 degrees to the positive x-axis. 4 units at an angle of 15 degrees to the positive x-axis. So the positive x-axis is like this part of the x-axis. Displacement of 4 units at an angle of 15 degrees. So 15 degrees, I don't know, is about like that maybe. And 4 units would be 1, 2, 3, 4. Okay? Vector notation, page 277. Draw a position vector from origin O to point A. Let's see. It can be referred to as vector OA or bold A, or A with a little line over it, or A with an arrow over it. Okay? So let's see. There's going to be an O. There's going to be an A. And then we just connect them with a directed line segment. AB is a vector which originates at A and terminates at B. Okay, so AB, A, and AB is the position vector of B relative to A. Okay, so they're just saying, these are two different ways of saying the same thing. So it's a position vector, starts at A, goes to B in the direction of B. Okay. Page 278, geometric vector equality. Two vectors are equal if they have the same direction and magnitude. Equal are parallel or in the same direction and are equal in length. The errors that represent them are translations of one another. Okay? So like, remember, translation is like you vertically move it, and that is translation. You don't change the direction of it at all. Vectors are the point that they start from doesn't matter. So if you have a vector here and a vector here and they're the same direction and size, then it doesn't matter that this one's to the left and this one's to the right. They're still equal.